2x minus 1 over x plus 3 minus x minus 2 over 2x plus 1. So let's talk about this a little bit, and then we'll transition into any other math questions you have. So we're looking at rational expressions, and we're learning how to add them. We're going to add them, subtract them, multiply them, and divide them. But we've already done a little bit of multiplying and dividing. That's where you have a rational expression with a polynomial that can be factored divided by another rational expression. So imagine you have a situation like this. We basically need a lowest common denominator. And the lowest common denominator between these two things is actually x plus 3, 2x plus 1. That is the lowest common denominator. That's the lowest common multiple, because there is nothing smaller that allows both of these to go into it without any issues. So if I'm looking for the LCD, then I need to change this and this to become like that. And the way I do that is I multiply both the top and bottom on the left by the thing I don't have, which is 2x plus 1. So imagine if I do 2x plus 1 over 2x plus 1. And then on the right side, imagine if I did x plus 3 over x plus 3. So this is the next part where you guys get to show if you know how to multiply your polynomials. Can I take this and multiply by that, and can you give me that answer here? And then take this and multiply by that and give me your answer here. And then it's subtracted, right? And then in the denominator, you can just write 2x plus 1, x plus 3, 2x plus 1, x plus 3. So we can do that in the denominators. And then in the numerators, I need to multiply this and I need to multiply that. For time purposes, you can actually, if some of you are watching this at home, you can pause this video and try it, and then come back and continue, okay? That's what I would recommend. So if you're not watching at home and you're in class, you can try out that problem as well. So let's go ahead and continue the problem. We're going to finish this problem out, and then I'll take more questions. So basically, we have 2x minus 1 divided by x plus 3 minus x minus 2 divided by 2x plus 1. I needed to have a common denominator, so I did x plus 3, 2x plus 1. And now I'm going to multiply 2x plus 1 into 2x minus 1 and x minus 2 into x plus 3. I want to write my answers here. We're going to simplify, and then I'll take questions from those on Zoom. So give me 1 second. So let's go ahead and FOIL that. That becomes 2x times 2x, which is 4x squared. And then 2x minus 1 there is minus 2x plus 2x minus 1. So basically, we've multiplied the top there to get these values. And we're going to do the same there. We're going to get x squared and then plus 3x minus 2x and minus 6. So we have those values as well. Again, this is a CLEP practice problem. This is actually number 42 from the CLEP practice. We're just looking at reviewing our understanding of polynomials. And so then this part becomes 4x squared minus 1 divided by 2x plus 1, x plus 3. And that part becomes x squared plus x minus 6 divided by 2x plus 1, and then x plus 3. Okay, so if we do that, we can technically distribute this negative into everything over there because we have common denominators now, and so we can add and subtract fractions when we have common denominators. So let's bring that work over here. We're going to have 4x squared minus 1 minus x squared minus x and plus 6 divided by 2x plus 1, x plus 3. So now in the numerator, we're going to have 3x squared and minus x, then minus 1 plus 6 plus 5, and then 2x plus 1, x plus 3. And then we ask ourselves, are there any two numbers that multiply to give 15, and add to give negative 1? That would tell us if we can continue doing this problem any further. But when we look at the answer key, or not the answer key, but when we look at the options they give us, one of the options is D, which is exactly like this. And so if I'm doing the CLEP test, I'll just recognize that is the answer, because they will not trick you with giving you this and another version of the answer. So that is the answer to that particular problem, and I will stop there, and we'll take questions on any other sections.